Welcome to my channel. Today we are going to discuss about the topic, the very important topic in DSP. It's a fast Fourier transform. Okay. What is fast Fourier transform means? The name implies it is this algorithm. It is used to perform the DFT of the given finite sequence in a very fastest manner. Okay. So that is nothing but a fast Fourier transform. So already we discussed in the previous videos what is the direct evaluation method in order to find the DFT of the given time domain sequence x of n. Okay, so the 4-point DFT, 8-point DFT, we solved so many problems. Okay, and inverse DFT problem also solved, and the properties of DFT is also discussed in the previous videos. Okay, so now that is what is the disadvantage in that direct evaluation method of DFT is that so the number of computations required to perform the direct evaluation DFT is very high. Okay, so in order to reduce the number of computations, that is the number of computation means the number of addition process, number of multiplication process used in order to find the capital X of k is a large number in the direct evaluation method. So in order to reduce the number of computations in order to perform the DFT, so we are using one special algorithm, one efficient and special algorithm. It is called as a fast Fourier transform. Okay. So what is the definition of this fast Fourier transform means? The fast Fourier transform, it is a highly efficient procedure or algorithm for computing the DFT of a finite sequence or series. Okay, so this procedure, this FFT is also used to find the DFT answer of any time domain signal x of n. Okay, so what is the answer? We got it from the direct evaluation method. The same answer we will get if you are using the FFT also. Okay, but what is the thing means? It is a very highly efficient algorithm. Okay, so what is mean by the highly efficient algorithm means? So this FFT, it requires a less number of computations than that of the direct evaluation of DFT. Okay, so if you that is for example you just take one 4-point DFT. So if you are if you want to do the 4-point DFT of the sequence x of n is equal to 1 comma 1 comma 0 comma 0. Okay, so in the direct evaluation DFT, the number of multiplications, the number of addition is very high when compared to this fast Fourier transform. So when we are using the fast Fourier transform in order to compute that 4-point DFT, it requires the number of addition process and number of multiplication processes very less number when compared to the direct evaluation method. So that's why this FFT, it is called as a highly efficient algorithm. Okay, this is the one thing. And another one thing is that so automatically if the number of computation, that is number of addition process, number of multiplication process reduces means so the automatically that computation time is also reduces in the FFT algorithm. Okay, so the FFT, it reduces the computation time required to compute the DFT. Okay, so that's why the performance of this FFT is increases by the factor 100 or more over the direct evaluation of DFT. So this is the very greatest advantage of this FFT over the direct evaluation method. Okay, so these are all the that is advantage. What is the main thing behind this fast Fourier transform? Okay, so the first thing is this fast Fourier transform. It is a highly efficient procedure in order to compute the DFT of the given finite sequence. Okay, and what is the difference between the direct evaluation DFT and this FFT means? It requires less number of computations than that of the direct evaluation DFT. Okay, so we will discuss in the next thing. So I will tell how many multiplication process and how many addition process required in the direct evaluation method and FFT. We will compare it. Okay, then automatically so this FFT, it reduces the computation time required to perform the DFT, automatically reduces. So that's why it improves the performance by the factor 100. Okay, so that is the thing. And in this FFT algorithm, so what we are doing means this FFT is based on decomposition and breaking the transform into smaller transform and combining them to get the total transform. Okay, that means what is the meaning means in this, if you want to perform if you, for example, if you want to perform 116-point DFT means that 16-point DFT. So first we are splitting that 16-point DFT into 8 2-point DFTs. Okay, then the 8 2-point DFTs are combined. Combined to get then again we are the answer for that 8 2-point DFT answer is again using the 4-point DFT. Then the 4-point DFT answer is again we have to perform it to 8-point DFT. Then finally we have to combine means that is the total answer for the 16-point DFT. Okay, so that's why the FFT is based on decomposition and breaking the transform into smaller transform. That is the 16-point DFT is first divided into 2 8-point. Then each 8-point DFT is again divided into 2 4-point. Then each 4-point DFT is again divided into 2-point DFT means BFT. So we are performing separately. Then we are combining the answer in order to get the total transform. So this concept, it is called as a fast Fourier transform. Okay. So then next one, we have to compare this DFT and FFT. So this comparison is a very important 2-mark question. Okay. Sometime that is the question, it will come as a, that is how many computations required in order to perform DFT in the direct evaluation method and fast Fourier transform method. This is the question. Okay, so how many computations or how many additions, how many multiplications are required in order to perform the DFT in direct evaluation method and fast Fourier transform method. It is a very, very important 2-mark question. Okay, so this is the one type of question. Then sometime the question may be find the number of addition process and multiplication process are required, that is to perform either that direct evaluation DFT and FFT. If you want to perform the 16-point DFT or 32-point DFT, that is the capital N value given, we have to find the number of addition process, number of multiplication process. Okay, so sometimes they may ask like that only. Okay, so here first that is the standard thing we have to discuss. So you see, if you want to perform the DFT in a direct evaluation method, okay, direct evaluation method is the formula method. Okay, the capital X of K is calculated as that summation K equal to n equal to 0 to n minus 1 x of n e power minus j 2 pi k n by n. Okay, so you know the formula, in that formula method, that method is called as a direct evaluation method. Okay, so if we want to perform one n-point DFT, here the capital N is a number of samples in the given x of n. Okay, so in order to perform the n-point DFT, so number of multiplication needed is n squared. Okay, for example, if we want to perform 4-point DFT means the number of multiplication is 4 squared. So 4 squared is 4 into 4, 16. And the number of addition required is n into n minus 1. So n into n minus 1 means 4 into 3. Okay, so 4 into 3, that number of additions we have to require in the direct evaluation method. Similarly, the same DFT answer we can obtain using the FFT algorithm. The FFT means fast Fourier transform algorithm. So in order to perform the same n-point DFT, so how many multiplication needed means n divided by 2 into log n. Okay, n divided by 2 into log n number of multiplications, and how many additions required means n into log n. Okay, n into log n additions are required. So if you are comparing these two computation means this n by 2 log n and n log n value is very less when compared to this n squared and n into n minus 1. Okay, so this is the that is the formula in order to find the number of multiplications, additions required in order to perform DFT in a direct method as well as the fast Fourier transform method. Okay, so it is a very, very important 2-mark question. Okay, so you just remember number of multiplication is n squared. Number of addition is n into n minus 1. Okay, then in a fast Fourier transform, n by 2 log n. Okay, to the base 2. And in the number of addition is n log n. Okay, twice the amount. This addition is twice the amount that of the multiplication process. Okay. So this is the one of the thing. Then using this one, so sometime the question may be, so here you see this a table. So in this table, I am comparing for a different value of n. Okay, so for different value of n, so how many additions and multiplications required in a direct evaluation method and as well as the FFT method, fast Fourier transform method you see. So here, if the number of, that is the endpoint DFT is, you just consider the capital N value as a 4. That is, if we want to perform the 4-point DFT, okay. So the number of samples in a given X of n is 4 means the capital N value equal to 4, okay. So at the time, that is the DFT answer is obtained in a direct evaluation method means, so in that case, already you know the number of multiplication required is n squared, okay. How many additions required in order to perform this direct evaluation? N into n minus 1. So what is the answer? So you see the number of addition is n into n minus 1. So 4 into 3. So 4 into 3 is 12. Okay. Similarly, the number of multiplication required is n squared. So n squared means 4 squared. So 4 squared is 16. Okay. So 4 squared is 16. This is the thing. Then if you want to perform the same 4-point DFT, using the FFT algorithm means the number of addition is n log n to the base 2 and the number of multiplication is n by 2 log n. Okay, so you see here number of addition if you want to compute means 4 into log of 4. Okay, so 4 into log of 4. So here that 4 it can be written as 2 to the power 2. Okay, so then log to the base 2 to the power 2 it can be written as 2. So 2 into 4 it is 8. Okay, so this is the answer. And the number of multiplication is, you see, let us compare these two formulas. So what is this? What is the relation between these two formula means? The half of the addition, it is said to be the number of multiplication. This is n log n. This is n by 2 log n. So that's why number of addition is 8 means number of multiplication is divided by 2. It is 4. Okay. So let us compare these two things. If we want to perform the 4-point DFT, number of addition required in a direct evaluation method is 12. But if it is a FFT method means the number of addition required is only 8. Okay, so number of computations automatically reduces. Similarly, you see the multiplication. Number of multiplication required is 16 in a direct method. If it is a FFT method, number of multiplication required is only 4. Okay, so that is far much reduced. Okay, so you see the comparison. So similarly, you see, if it is a 8-point DFT, if you want to perform the 8-point DFT means the number of addition. Similarly, using this formula, you just find out the answers. Number of addition needed is 56. Number of multiplication is 8 squared. It's a 64. Similarly, in a FFT algorithm, you have to substitute in this formula n log n. So the 24 and 12. Okay. Similarly, if it is a 16-point DFT means, so the number of addition is 240. Number of multiplication is 256. Here you see number of addition just 64 and number of multiplication 32. Okay. So when we are increasing this n, okay, when we are increasing this capital N value, so there is a far difference between the computation. So you see number of addition 240, but in this FFT algorithm only 64. So here you see the multiplication, it is 256, but in this case it is reduced to only 32. Okay, similarly, you see if it is a 32-point DFT means you just compare it, it's a 992, but here only the addition is 160. Multiplication is 1024 multiplication required, but here the only multiplication is 80. Okay, similarly, if it is a 64-point DFT, you see 4032 addition, 4096 multiplication, but here only 384 additions and 192 multiplications. Okay. So when number of that is the number of point DFT increases means the number of the computation process is far much reduces when compared to the direct evaluation method. Okay. So sometime the question, the 2 mark question, it will come like that. That is how many additions and multiplications required in order to perform 16-point DFT in a direct evaluation method and the fast Fourier transform method. Means you have to write like this. So 16-point DFT means number of number of addition in direct evaluation is 240. Okay, so just you remember this formula. So for whatever the value of n, you just substitute in the formula. Okay, so you should remember this formula. In direct evaluation, n into n minus 1 addition, n squared multiplication. But in the case of FFT, n log n addition, n by 2 log n multiplications. Okay, so using this formula, you just find and write down the answers. Okay, so it's a very important 2 mark question in this thing. Okay, in this topic. And the next one, what are the applications of this FFT means? So, so wherever the DFT is applicable, at that case, we have to use this FFT algorithm. Okay. So applications of the FFT computation technique is used in spectral analysis. Okay. So if you want to find the spectrum, okay, what does mean by spectrum? That is the frequency spectrum. The capital X of K versus the various values of K. It is said to be the spectral analysis. So in order to compute, in order to obtain the spectral analysis, we are using this FFT algorithm. And in a filter simulation, if you want to design some filters means we may use this FFT, and it is used in the process of autocorrelation and pattern recognition. So these things, we will use this FFT algorithm. So these are all the applications of FFT. Okay, and the next one, there are two types of FFT algorithm is there. Okay, so the FFT algorithm, it is a fast Fourier transform. It's a highly efficient algorithm in order to perform the DFT answer in a very fastest manner with less number of computations. Okay, that is the FFT algorithm. So there are two basic classes of FFT algorithm is there. One is DIT. DIT means decimation in time algorithm. Okay, another one is DIF. DIF means decimation in frequency algorithm. So decimation in time algorithm and decimation in frequency algorithm. Okay, so if you are using any method, we will get the same answer only. And what is the difference between this DIT algorithm and DIF algorithm means? So in DIT algorithm, DIT means decimation in time algorithm. So in this, the sequence that is for which sequence we are going to perform the DFT, that sequence is successively divided into smaller sequences. Okay, that is first thing. If you want to perform the 4-point DFT means that 4 input sample is first divided into two 2-point DFTs. Okay, first 2 sample, next 2 samples. Okay, so for first 2 sample we have to perform one 2-point DFT. For next 2 sample we have to perform one 2-point DFT. Then the 2 answer we have to combine it. Okay, that is the total 4-point DFT of that one. Okay, so in this case successfully divided into smaller sequences, and the DFT of these subsequences are combined in a certain pattern to obtain the required DFT. Okay, this is said to be the DIT algorithm. Okay, then in DIF algorithm, the frequency samples of the DFT are decomposed into smaller and smaller subsequences in a similar manner. Okay, so in this thing, the X of K value is decomposed into smaller and smaller sequences in a similar manner. Okay, this is said to be the DIF. Okay, decimation in time means if the time domain sequence is divided into smaller and smaller sequences, we will perform and we have to combine. In DIF algorithm, the frequency samples is decomposed into smaller and smaller subsequences. We are performing it. Okay, in a DIF algorithm. So in the next video, we will discuss about this DIT and DIF algorithm in a very detailed manner. And so another one, the 2-mark question is that radix 2 algorithm. Okay, that is the other name of the FFT. Other name of FFT, either DIT or DIF algorithm, it is called as a radix 2 FFT. Okay, so why this FFT it is called as a radix 2 FFT means, so this DIT and DIF FFT algorithm, it is also known as radix 2. which means the number of output points, okay, capital N, it can be expressed as a power of 2. That is, what is the meaning? Means using this FFT, we can perform 2-point FFT, then 4-point FFT, then 8-point FFT, 16-point FFT, then 32, and so on. So you see these values. So in that case, in the first thing, what is the capital N value? 2 to the power 1. In the second case, capital N equal to 4. The 4 can be written as 2 to the power 2. In third case, capital N can be written as N equal to 8. The 8 can be written as 2 to the power 3. In 16 means 2 to the power 4. Okay. So the number of output points. Okay. So number of outputs obtained from the FFT N, capital N, it can be expressed as a power of 2. Okay. Compulsory, the capital N value, it can be written as a 2 to the power some m, where m is a integer. M is equal to 1, 2, 3, 4, etc. Okay. That's why this FFT algorithm, it is also called as radix 2 algorithm. Okay. So using this FFT, we can perform 2-point DFT, 4-point DFT, 8-point DFT, 16-point, 32, 64, 128, etc. That is 2 to the powers only we can obtain. Okay. So there is no 6-point FFT algorithm. There is no 15-point FFT algorithm. Okay. So always the number of outputs produced in the algorithm is only in the power of 2 power. Okay. That's why this FFT algorithm is otherwise called as radix 2. So this is also one of the important 2-mark question. Okay. So in the next video, so we have to that is solve the DFT problem using this DIT algorithm and DIF algorithm, and we will discuss about what is the difference between DIT and DIF in a detailed manner. Okay. So thanks for watching my channel, and please subscribe my channel for more videos. Thank you.